Okay, boys and girls, we're going to do some problem solving today. So first, let's watch our video while we talk about the problem solving we're going to do. We're going to be using some math models. And we've used math models before. We used them yesterday. And when we're talking about math models, we could be talking about using equations, or drawing pictures, or using our bar diagrams. So let's watch our video and we're going to find out what we're going to be working on and using today, in today's lesson.
How can you model with math? Think about this question during the lesson. David has $583 to spend on soccer uniforms. He buys this soccer jersey and 2 soccer shorts. How much money does David spend? Think, what math do I need to use to solve this problem?
Okay, so what math do we need to use to solve this problem? What are you thinking about, boys and girls? What math do you think we need to use?
I need to show what I know and then choose the needed operations. Think, how can I model with math? I can apply math I know to solve the problem, use a bar diagram and equations to represent the problem, and use an unknown to represent the number I am trying to find. A bar diagram represents something visually. Explain why a bar diagram is a model.
So why is a bar diagram a model? Do you know why a bar diagram is a model? We've used a bar diagram many times. Why does it model? Do you know why it models? Think about that. Because does it visually represent numbers and words in a problem?
A bar diagram shows or visually represents the numbers and words in a problem. Here's my thinking. I will use a bar diagram and an equation. The hidden question is, how much does David spend on shorts? $35 plus $35 equals $70. The 2 pairs of shorts cost $70. I need to find the total amount of money David spends for the jersey and the shorts. $70 plus $109 equals $179. David spends $179. Great job! Why is it necessary to answer the hidden question about the shorts?
So why do we need to know that? Can we figure out the problem if we don't know how much David spends on shorts? No, we can't figure it out because he buys 2 pairs of shorts. So let's try it. Oh, too late. I went past it. Sorry, boys and girls. Oh, we could click on the hotspots. So no, I didn't go past it. So we click on the hotspots to find how the information in the problem is related to the model used to solve it. So first off, here's our model. Here's our bar diagram.
This problem includes extra information not used in the solution.
Okay, so we have information we don't need. Sometimes the problem will present us with extra information that we don't use at all. So we have this information. He buys this soccer jersey.
The label gives the cost of the jersey.
$109, right there. 2 soccer shorts.
You need to answer a hidden question. What is the cost of 2 pairs of soccer shorts?
So each pair of soccer shorts cost $35. So we add 35 plus 35, which equals $70. So we know that David spent $70 plus $109 on his soccer uniform.
It is necessary to answer the hidden question about the shorts because you need to know how much 2 pairs of shorts cost. You can then add their combined cost to the price of the jersey to to find out how much money David spends in all. Now you know how to model with math.
Okay, boys and girls, now we're going to go ahead and we're going to practice. So I'm going to get our student addition out for you. And what I have is our cube strategy, which is going to help us solve our problems here. And I'm going to go right to our practice. That's what we just did. And so here's our problem. This is what we have, boys and girls. Let's read our problem. I'm going to get my pen here because I might need to write. It says Harris's office building has 126 windows. Morgan's bank has 146 windows. Devon's bank has 110 windows. How many more windows do the banks have than the office building? Now here our friendly helper says you can model with math by using bar diagrams to represent each step of a two-step problem. So this is a two-step problem. So here's what we like to do to help us figure out our two-step problems or any of our math problems. The first thing we're going to do is we're going to circle our important numbers. So we do have important numbers in our problem. We have our about Harris's office building. We're going to need that information because we want to know how many more windows do the banks have than the office building. So I'm going to circle the 126. We're going to circle the 146 because we need that information. And I'm going to circle the 110. Those are all important numbers in our problem. Now, we're going to underline the question we need to answer. We want to know how many more windows do the banks have than the office building. So I'm going to underline that right now. Okay, that's our ultimate question. Now I'm going to box some keywords. Now we often have keywords in math. Our keyword here is how many more. Those are the keywords, so I'm going to box that. How many more? Okay, so that's going to help me here. Now, I'm going to eliminate any unnecessary information. I don't think I have any unnecessary information in this problem today, so we're good there. Now, here's what we're going to start to do. Now it says, what is the hidden question we need to answer before we could solve the problem? What do you think the hidden question is? Well, boys and girls, I see here, so let me reread our question. That'll help us. It says Harris's office building has 126 windows. Morgan's bank has 146 windows. Devon's bank has 110 windows. How many more windows do the banks have than the office building? So what I'm noticing here is that windows and banks. So I have two numbers dealing with the banks. So what I'm going to have to do is I'm going to have to figure out how many windows are in the banks. So how many windows do the banks have in all? That's going to be my hidden question. I'm going to write that. How many windows? So we're going to write this. How many windows do the banks have in all? Okay, now I can solve that right here by writing my windows in banks. So 146 and 110. Okay, now I'm going to solve the problem. So first I'm going to solve my 146 plus 110 equals what? I don't know that, And I'm going to put it here, 146 plus 110. That equals, boys and girls, 256. 256 windows. So I know that there are 256 windows in the banks. Okay? So now, but we're not done yet, boys and girls. Now, we have our banks, and I can put that number right there. That's 256, right? So now, boys and girls, now what do we have to do here? Now, how many are in Harris's office building? 126. Now, I know I want to know how many more are in the banks than the office building. So that always tells me to do what, boys and girls? It tells me I'm going to have to do what? I'm going to have to subtract. So I'm going to subtract 256 minus 126, and that is going to equal 130. 130 more windows. Okay, 130 more windows for the banks. I'm going to write that so we are clear for the banks. So that's what we did. We used our models. It was very helpful for us to keep track of our data, of our numbers. Did everybody get that? Now you could have either been using your paper or I attached these pages for you. Okay? Did everybody get that? Now, let's look here. Now we have more practice. This is about a bakery, so let's see what we could come up with. It says, Regina's bakery made 304 pies in January. Her bakery made 34 fewer pies in February. How many pies did her bakery make in both months? Oh, this is like a little brain teaser. I love it. So, what is the hidden question you need to answer before you can solve the problem? So first, let's use our cube strategy. Let's circle our important numbers. Here's our important numbers. That would be an important number, 304. And what would be another important number here? How about this? 34. Now we also want to underline the question we need to answer. How many pies did her bakery make in both months? Box some keywords. I'm going to box the word fewer, right? How many is a keyword. Both months, that's another keyword, okay? So now, let's look at this. Now, boys and girls, it says, what is the hidden question you need to answer before you can solve the problem? So, we know how many she made in January. Do we know how many pies she made in February? Do we have to figure that out? Yes. So that is the hidden question. We have to figure out how many pies did they bake in February. So that's our hidden question. So how many pies did the bakery bake in February? So let's write that. So let's write how many pies were baked in February. Because 34 is not that number. Were baked in February. Because we know there was 34 fewer. 34 fewer than what? 304, so we have to figure that out. So here's what we're going to do. So this diagram goes right with this. So we know the total of pies. What is the total of pies? 304, so we're going to write that right here. right? Now, we don't know this number. This is the number that we don't know. This is what we do know. We know it's 34, because of 34 fewer. We should kind of have a line here. I don't know why we don't. Because this is the whole, 34, and this is 304, that's the whole. This is part, 34. What part is 34 of 304? That's what we're going to figure out, boys and girls. Now it says solve the problem. Complete the bar diagrams. Show the equations you use. So the first thing we're going to do, boys and girls, is we're going to have to make an equation. Now we're trying to figure out what this missing part is. To figure out this missing part, this is the whole, this is the part, one part of that whole. That means we're going to have a subtraction problem. So let's do that. So we're going to have 304 minus 34. And I hope you're all going to figure that out. You could pause and then figure it out. That is got, we'll have our missing, our unknown number. And then when we figure that out, it is going to equal what, boys and girls? 304 minus 34 equals 270. So this number is 270, so they baked 270 pies in February. So now, here's what we're going to do. We're going to put a question mark here. So now we know how many pies they baked in January. How many did they bake in January? They baked 304 pies. Okay, now I'm going to put a line there because that's our January, and here's our February, 270. So now I could figure out, or we could figure out how many pies they baked in January and February. How am I going to do that, boys and girls? What do we do to figure out how many pies they baked in all? We're going to add it. So now I'm going to add. So first we're going to write our equation, 304 plus 270 equals an unknown number. Now I'm going to write 304 plus 270. And boys and girls, what are you going to get when you add that? 574. Okay? Now, boys and girls, here we have a question. So we have 574 pies. How would your equation change if the bakery made 34 more pies in February than January? What would we do? What do you think we would do? If you said we would add 304 plus 34, you would be correct instead of subtracting it. So let's write that. So let's say I would add 304 plus 34 equals, and we don't know what it is, instead of subtracting 304 minus 34 equals, to find the number of pies. Okay, so that's what we would do. See, we go step by step, we look at our numbers, we look to see what they want us to do, okay? I'll give you a second to write that. Okay, now boys and girls, we're going to go to our next page because we have a very interesting problem on the next page. So you can either be using the page that I included or you could be writing on your paper. Now this one is about the Empire State Building and some other tall buildings. So we have the Empire State Building. This is called Skyscraper Heights. The Empire State Building in New York is 159 meters taller than the Republic Plaza in Denver. The John Hancock Building in Chicago is 122 meters taller than the Republic Plaza. The Empire State Building is 712 miles away from the Hancock Building. The Hancock Building is 920 miles away from the Republic Plaza. Manuel wants to know how tall the Hancock Building is. Answer exercises 6 to 9 to solve the problem. Okay, we have a lot of information there. So let's use our cube strategy. Step 1, circle important numbers. So, the Empire State Building in New York is 159 meters taller. So that is an important number, because that's what we want to know. The Hancock Building in Chicago is 122 meters taller. Okay, so that's an important number. Do you think this is an important number? The Empire State Building is 712 miles away. Here's our important question. Wants to know how tall the Hancock Building is. Let's underline, I'm thinking maybe that might not be an important number. And I'll tell you why in a second. Let's go to underline the question we want to answer. Manuel wants to know how tall the Hancock Building is. We have something here that says eliminate unnecessary information. Boys and girls, I think we have unnecessary information, which is kind of making this a tricky problem to look at because we're seeing a lot of numbers here. So you know what I'm going to do? I'm going to X out this because we don't need to know that. Okay? We don't need to know those numbers. They have nothing to do with how tall the building is. Okay, now, so we're going to box some keywords. How about if we boxes taller than? That seems like that could be important. Okay. So now let's start solving. So, our first problem here says, to solve the problem, should you add 159 to the height of the Empire State Building? Explain why or why not. What do you think? Should we add that? So let's read our information again. The Empire State Building in New York is 159 meters taller than the Republic Plaza in Denver. The John Hancock Building in Chicago is 122 meters taller than the Republic Plaza. Would we do that? What do you think, boys and girls? I hope you're saying no, we should not. No, we're not going to, because the Republic Plaza is shorter than the Empire State Building. So its height will be less than 381 meters. So no, we're not going to do that. We're not going to add to the height of the Republic Plaza. So, or to the height of the Empire State Building. We're not adding to those buildings. So let's say no. So let's say no. So say no, the Republic Plaza is shorter than the Empire State Building. So its height will be less than 381 meters. Okay, I'll give you a minute to write that. Okay, now, what is the hidden question you need to solve in this problem? Draw a bar diagram and write an equation to represent the hidden question. So what don't we know? It says the Empire State Building in New York is 159 meters taller than the Republic Plaza in Denver. The John Hancock Building in Chicago is 122 meters taller than the Republic Plaza. Well, what don't we know the height of? We don't know the height of the Republic Plaza in Denver. So let's say that that is our hidden question. We don't know the height, how tall the Republic Plaza is. The height of the Republic Plaza. Okay, now boys and girls, and how are we going to figure that out? Let's do a bar diagram. So we know the Empire State Building is 381, right? And now we're going to have our missing numbers here. Right? And we have a question mark there because we don't know what it is. So now we're going to have to subtract it. So we're going to have to subtract 381 minus 159 equals we don't know, right? So boys and girls, we're going to have to solve it. We solve it here because we have this section here. It says model with math. Solve the problem. Show the equations you used. So we're going to subtract 381 minus 159 equals what? Everybody figure that out. I'll give you a minute to figure that out. Okay. Did you figure it out? It is what? It is 222 meters. Okay, now we know, did I say 222? 381 minus 159 is 222 meters. Now boys and girls, now we have to figure out our next equation. Okay? Now we know that we have got our missing, let me move up, oops. Now the John Hancock Building is 122 meters taller than the Republic Plaza. So I'm going to draw another one, we're going to draw another bar diagram. 22, right? And then this is our unknown number here. We don't know. Okay? We don't know what that is. So now we're going to add it. We're going to add our 222 meters plus our 122 meters taller, which is the John Hancock, which equals 344 meters. And so the Hancock building is 344 meters tall. Okay, and so now, boys and girls, which tool would you use to represent and how to solve the problem? So if we wanted to show all these things, what could we use to show it? We could use counters, cubes, or place value blocks? What would be the best? Because we're working in hundreds. Place value blocks. That's what I would use. Place value blocks. Would represent hundreds, tens, and ones. And ones. Okay, there you go. So we were able to figure it all out by going step by step. There we go. Good job, boys and girls. Good job. And now you can do your practice buddy. So I'll give you a second to look at that. And you can always pause the video